Hello and welcome to this video about adding and subtracting rational expressions. The learning target of this lesson is knowing how to add and subtract rational expressions. So there are a few core ideas that I want to talk about first when we're talking about adding and subtracting rational fractions. First, keep in mind, these are fractions. So anything that you have to do with fractions is something you have to do with these rational expressions. So really, when we're talking about adding and subtracting, and these are fractions, that boils down to have a common denominator. Common denominator. Second thing, and this falls under the sort of the tips category, that is, use the distributive property or be familiar, distributive property, especially when it comes to negatives. And so that's another tip. So watch out for negative signs. And really what that means is you really have to use parentheses. Keep an eye on all of that stuff because as you'll see when we walk through some examples, it's not that complex. It's just keeping everything organized and in its place and knowing what combines with what is key. And so from here, let's just kind of jump into some examples and see what we have. So right off the bat, we'll start off with something that's fairly straightforward. Let's say we have something like 4t over 5xy plus 7 over 5xy. Okay, now this might look complicated, but just think about this as a fraction. I'm going to change this. Let's say this was 4 over 5 plus 7 over 5. So what I just did is I removed the variables to make a point. We have common denominators, and so what we can do is we can add these together. Now, the difference with this is that we have a variable on one of them, and so we'll just put that variable here. Can we combine 4t and 7? No. The best we can say is 4t plus 7, and we'd put that over 5. Well, that idea, that concept is going to hold steady with a more complex fraction, this 5x minus y. And so, let me switch colors here. We already have a common denominator. Our denominator is going to stay the same, 5xy. Now we add these together, 4t plus 7. So if the denominator is the same, it's all good, and it's really easy. We just have to bring them together. Let's look at another example, and this one's a little more complex. Let's say we have 5n over n plus 3 plus 15 over n plus 3. Now, as it stands, we have the same denominator. So we can just add these together. So our denominator is going to be n plus 3. And then here we have 5n plus 15. And now we have to check one more thing. You know, just like with a fraction, sometimes when you add fractions, you're able to reduce them at the end. And that's what we're going to be able to do here, because what I can do is take out a 5, and I'll have n plus 3 over n plus 3. And the n plus 3's cancel out, and I'm simply left with 5. And that's my final answer for that one. So, we saw some examples of adding when we have common denominators. Now, let's take a look at an example when we have subtraction with common denominators. So this is our third example. And let's say we have 3x minus 5 over x plus 4 minus 4x plus 2 over x plus 4. Now here's where we have to be careful, because we have a negative sign right there. And what I'm also seeing is that we have the same denominator. So that's good. So what we're going to do is apply this negative to just the numerator. So again, another hint I had was use parentheses, so we get that this is a distribution. So what I'm going to do, take my time here, and I'm going to rewrite the problem. 3x minus 5 over x plus 4 plus, and then what I'm going to do is I'm going to put this minus sign, I'm going to distribute the minus sign. Negative 4x plus 2, oh, no, whoa, so you got to watch out. Minus 2 all over x plus 4. Now, I have the same denominator, so I can bring these together over that denominator of x plus 4. Excuse me. And now, this is about combining like terms. So, I have a 3x and a negative 4x. 3 minus 4 is negative 1x, and then negative 5 and negative 2, negative 7. box it, walk away. Now, just to throw it out there, you may also see it, or later on, as something like negative x plus 7 over x plus 4. That's the same thing with just the negative factored out. So sometimes people like to keep x's positive and they'll put the negative sign outside to do that. That's one of those things, 6 in one, 1/2 dozen in the other. It's the same, just looks different. All right, now let's talk about what we do when we do not have a common denominator. And so in that case, for our fourth example, let's say we have b plus 3 over b plus b minus 5 over b plus 1. All right, so now we have to focus in on the denominators. And just for a second, let's kind of think about real fractions here. And let's say we had something like 5/6 plus 3/10. What would we do in a situation like this, where we don't have a similar denominator? Well, we would ask ourselves, what's the common denominator between 6 and 10? And we would end up getting 30. And so we'd multiply by 3 over 3, and then we'd go 5 over 5, and then we can add and subtract these together. Same idea. So we have to ask ourselves, what's the common denominator of b and b plus 1? Shortcut to that is just to multiply them together. So our common denominator, that's what CD stands for, is b times b plus 1. So if I take a look at this fraction on the right, what it's missing from my common denominator is the b. So I'm going to multiply both the top and bottom by b. This guy on the left is missing the b plus 1. So I'm going to times both the top and bottom by b plus 1, b plus 1. Now, pro tip, keep your denominator factored out. So our common denominator is b plus 1. And since this is a plus sign, what I'm going to do is I'm going to bring it all together. Or actually, no, I'll write it as two separate fractions. I take that back. All right, b plus 1. Okay, here I'll FOIL that out. b squared, and then 1b, 3b for 4b plus 3, plus, and then here I'll get b squared minus 5b. Now we have common denominators, so we can keep that the same. Let me scroll down a little further here. So we have b times the quantity b plus 1, and then we have 1b squared, 2b squared for 2b squared. And then let's see here, we can 4b minus 5b is minus b, and then plus 3. Now, we may think that we're done, and we could be. But before we box it and walk away, let's just do a little bit of scratch work. So 2b squared minus b plus 3. If I were to factor this, could I simplify it to where I could cross something out? And again, another pro tip, I'm going to use this factor to help me out. If I were to put b plus 1, could this be 2b plus 3? No. So that's not going to work out because just the way the signs are working, this is not a thing, and this is as far as we can take it. Let's do one final example here. All right, so let's say we have 3x plus 2. Let me make that a better 2. 3x plus 2 over x squared minus 2x minus 3 plus x plus 1 over x minus 3. All right, so now here, what we're going to do is factor out this denominator right off the bat to see what's going on. When I do that, I'm going to get x minus 3, x plus 1. And so when I ask myself, what's the common denominator between these two fractions, it's going to be this one right here, x minus 3, x plus 1. And so this has everything it needs. I don't need to do anything. But the fraction on the right, I'll need to multiply by x plus 1 over x plus 1. Just to give you a quick analogy, this is doing something like, say we had 5/12 plus 1/3. The common denominator for 12 and 3 is 12. And so I would only need to multiply this by 4 over 4, and I don't have to do anything to the 5/12. It's the same idea, but instead of with a larger number, we're dealing with a quadratic or a polynomial in this case. So back to the work at hand. My common denominator is x minus 3, x plus 1. This numerator is still 3x plus 2. But this one is now going to become x squared plus 2x plus 2 over that same common denominator, x minus 3, x plus 1. And now combine some like terms. So I have x squared plus 5x plus 4 over x minus 3, x plus 1. Now again, you might be tempted to box it and walk away. However, we can factor this to become x plus 4, x plus 1. And we do that, the x plus 1's go away, leaving us with a final answer of x plus 4 over x minus 3. Now we can box it and walk away. So this might be a lot to process, but just kind of go back to the core ideas here, which are, these are fractions. And so if we're going to add or subtract, we have to have a common denominator, and then only the numerator gets manipulated and changed. Sometimes, especially with subtraction, you're going to need that distributive property because you have to watch out for negatives, and you're going to want to use parentheses to help you with that. So good luck with your homework, and let me know if you have any questions.